Hello, Daniel.
I'm fine, thanks, sir.
Yeah, good evening. So I think today, uh, since I'm not sure how many members are joining, so we can just proceed. And I wanted to ask you about the progress and report of what we have been discussed in the last meeting. So maybe if you have update, let me know.
Yes, I do.
Yep.
And we've already ascertained that the mild steel pipe will hold the blast. The pressure required and the operating pressure of the pipe are okay to be used.
Mm-hmm.
And the only one issue, which was raised by members from my team, was that using the mild steel pipe, the weight was bound to increase
Mm.
greatly as compared to aluminium, which was a concern they wanted me to forward.
Mm.
And Jeremiah from the airframe team talked about how the pipe's external radius is smaller than the motor holder units they had created. So it was a point of concern for them since the pipe is smaller than the aluminum one which they had originally designed their motor holders for.
Mm-hmm.
That's all. And Nefat and Samil went to look for the boring tool. I still haven't gotten any feedback from them.
Okay, so the Samir and the Nefat went to look for what? What?
The boring tool.
Boring tool. Oh, okay, okay.
Yeah.
I see. Okay. Now, so you mentioned about the increase of the weight. Um, when we use a steel pipe, did you calculate the how much we are going to increase?
We still haven't cut the pipe to the required length.
Mm-hmm.
So it was just an observation from intuition because
Mm.
as we were machining and holding the pipe supposed to do the 3 grain test,
Mm.
we felt that it was vastly heavier than the aluminium casing.
Mm-hmm.
So
Mm-hmm.
it was a point of concern since
Mm.
that 3 grain casing, we had already bored it a bit and it was still heavier. So we
Mm.
assumed that a pipe that hasn't been bound is bound
Mm.
to be heavier than what
I
we were
see.
working with.
Yeah, I understand. I think the maybe the best approach is to measure the actual weight. But before that, I think we can still calculate or estimate because we know the dimension of the steel pipe, thickness, diameter, length. Then we can calculate the volume. Then we know the density of the mild steel, so we can just estimate, right? Daniel, do you agree?
Yes, I agree. Yes, I agree. I'm
Yeah.
going to perform calculations and forward the results.
Yes. And okay, I need to confirm, but this impact of the increase of the mass, I think it should be reflected on the open rocket simulation. So, is it where do we enter such mass information? Is it on the open rocket or is it on the open motor? We include such information of the mass.
Open Rocket is just for simulating the thrust curve and
Hmm.
the thrust we'll be getting.
Yes.
The mass the mass considerations were taken by the airframe team when they were designing the
Hmm.
fins. I remember they asked me for the weight before they could even design the fins, and
Hmm.
they were used the weight in the open rockets to design the entire body.
I see. In that case, I think you should hand over the information of the casing in terms of weight to the airframe team or Jeremiah.
I will do that.
Yeah, thank you. And of course, you can share the information on the Discord so that we can, all of us can know.
Okay, I will do that.
Yeah, thank you very much. And okay, boring tour and steel pipe. Yeah, that is good. Now, do you expect to have a static test?
The team members, we discussed about finding a thermal insulator
Mm-hmm.
and improving on our ignition system, which we had tested a bit and we got better results from the last static test.
Mm-hmm.
So if we were to do a static test before launch, it was meant to find the best insulator for the aluminum casing and test out our
Mm.
ignition system, since we noticed in order to ignite the
Mm.
rocket properly, we need to multi-ignite the 4 grains simultaneously.
Yes. So you mentioned the issue of thermal insulator. So in the last static test, so do you think there was an issue of thermal insulator?
The last one, there wasn't an issue, but that was mild steel. We had no concern for protecting it, but with aluminium, we were advised from the first batch students to take extra caution with it.
Mm-hmm. I see, I see. I understand. Any improvement for the grains?
As of recently, the grains were performing properly ever since Washington came over. Their cooking technique has enabled us to improve the
Ah,
results we are getting from the grains.
that sounds super. So when was it? While I was away?
Um, the grains we cooked with them were used while you were away. The static test which was performed while you were away.
Okay. Did you, yeah, actually, I wanted to know the difference of between the theoretical performance and your actual experiment. How was it compared to ideal theoretical value?
Uh, we got half, around half of the expected impulse.
Mm-hmm.
We got 480,
Mm-hmm.
which uh, which was half the 1,000 we were expecting.
Mm. 400,
So
480 Newton.
yes,
It's a peak thrust.
yes, that was the
Ah.
no,
Mm.
that was the entire
Oh,
uh, impulse.
okay. 480 Newton seconds, right?
Yes, yes.
Thank you. Yeah, I think, okay, that's a good progress. So, when do you expect to have the next static test?
We still haven't discussed with the members on their availability,
Mm-hmm.
but if all goes well, we can cook and we can probably use we'll intensify our search for the insulator. And if all goes well, we have 3 grains already at the cupboard over there. We just need one
Mm-hmm.
if we are to test the 4 grain system, and probably we are to get a new load cell that can withstand the expected thrust.
Okay. Yeah, thank you very much. And finally, okay, let me open Nakuja GitHub. I think I can share my screen. Nakuja, oh, this is not launch preparation. So, all right, so nobody shared an issue, so you can, oh, just a moment. Okay, so let me. Yeah, what I wanted to say is that everybody is responsible for putting issues. Now, so you mentioned anything, and you assign someone, Nefat and Samir, and static test or static test or scheduling static test. So kindly define all the issues you are working on or you will work on. The armor insulator. You can modify the title. This is just an example. And also uh, the calculation of the casing mass for the high-based casing. And what? Yeah, you can just continue and complete. Yeah, so this is not only for Daniel and but for everyone. So we have to summarize all the issues, okay? Yeah. So thank you very much, Daniel. Do you have something else to report?
Nothing. I have nothing. I will inform you if anything arises.
Okay, thank you very much. So in the next meeting, I think it will be on Wednesday. So we are going to keep track the update. So thank you. All right, so anybody from other teams? So we have heard from propulsion. Maybe, do you have any update from avionics or recovery? Or even airframe? Any update? I can see some, okay, progress for avionics or recovery. Any update from recovery team?
Good evening.
Good evening.
Speaking on behalf of the Recovery and Avionics, we've just had a meeting.
Yes.
And we sat down and first discussed what was able to be done, especially with batch 2 and during the last drone test. So a couple of issues were identified, especially with regards to the flight computer and the power distribution board. There was an issue where the flight computer could not receive power from the power distribution board, although the power distribution board was working correctly. So we've decided we're going to combine the two into one PCB just to cut off any problems that might have been there while trying to transfer power. And then as a result, we've also decided to go with fabricating and getting the PCBs from JLC PCB. So we have a 2 weeks timeline to have redesigned everything and tested and hopefully send them in time. So we want to do it by the second week of October. I'm not sure if that poses a problem with regards to the timeline.
Moment. Let me check the JLC PCB lead time. All right, just for fabrication, I think it can take a day because we are not making too many. But if in case of assembly, so do you request to assemble, right?
Preferably, yes.
Okay. Yeah, of course, it depends on the shipping time or delivery time. So
Yeah.
It is saying as quickly as 7 days. So, well, vary from 5 to 20 days. Okay. Yeah, but of course we have to count on the time for testing. So
Yeah.
okay, 2 weeks time, I think. Yeah, I think yeah, would be possible. Yeah, but in that case, yeah, if we can complete in 2 weeks, I think, yeah, we can just good to go.
I think, thank you. We'll work on that and provide progress. I'll update everything we've done today on GitHub and also send the slides to the group.
All right.
So then there was also with regards to the recovery team, the recovery section. It was noted that during the ejection test, the 20-gram crimson launched everything and it broke a couple of things within the airframe. So we decided we're going to do a second ejection test, but this time reduce the amount of crimson powder. That's what we've decided upon, but we don't have a specific timeline yet because you still have to refabricate everything that broke. So I think we'll be updating this as we go.
All right. So I think I'm not familiar with the issue. So what happened?
From what Eric reported, there was an ejection test and they used 20 grams of crimson and either is able to be ejected. However, it broke a match that were holding it, which again faces a problem because you can imagine if you're on the rocket, then imagine the entire rocket will break off. So Eric suggested that we reduce the amount of crimson powder to be used to become slightly lower, so around 10 grams. So that's the current test that we're working towards. However, we can't give a timeline on when we want to do the test because everything that broke has to be redesigned and refabricated rather. So we will just update as we go.
Let's see. So do you can you identify what has been broken? Like what is everything?
Let me allow Eric to speak on his behalf because I also had a bit of a concern
No
on the
problem.
things that fully broke off.
Okay. Unfortunately, I don't see Eric joining. Are there?
He is.
Is there?
He's there.
Oh,
Hello.
he's there. Ah, okay. Yeah. Good evening. Go ahead.
Can you?
Eric.
Can you hear me?
Still
Hello?
connection issue, but okay. Hello.
Stuff that broke during the test was the parachute bay where the parachute was behind the piston and the piston chamber, the chamber that held the crimson power, not the stuff that broke. Yeah, so we need to refabricate that, which will not take long. I think 2 weeks at most, 1 week at best, can have everything ready for that test.
Okay. Thank you very much, Eric. Yes. Nevertheless, I was not able to hear everything. So maybe kindly visit this GitHub issue and continue to add the comments. Yeah, I just want to summarize what has been broken and what we have to recreate for the next ejection test. But I was glad to hear that yes, so we hope we are going to start the next ejection test in 2 weeks. So yeah. So timeline is the key. So I want to summarize the Gantt chart for each team to work on what in which timing. So yeah, thank you for your report, Eric. And as I said, please summarize the tasks and also the components you are going to create. Yeah, I hope Eric got it. All right, and I had a question for June. So June mentioned she had an issue for flight control board, and the power distribution board was not able to source to flight control. But I think maybe June meant PCB for telemetry board, right? Because the flight control board is something Bob is considering for his active tail fin control system. Yes. So I think, yeah, this and this, right? Power distribution and telemetry board.
Yes, apologies. Yes.
Yeah. So, and your suggestion is that you're going to merge or integrate this and this, right?
Yes.
Okay. I understand. So this will be integrated. Now, my question is, if you are going to order the PCB to JRC PCB, how many kinds of boards or how many kinds of PCBs are you going to order? So my understanding is 1 and 2. One PCB for ejection, one PCB for these 4 functions. Am I right?
Yes, you are.
Good. Yeah, thank you. And I think, yeah, I wish Bob was there, but yeah, so tomorrow I'm going to have a meeting with Bob and to discuss this issue. So how he's going to go about it, how he can implement his flight control code. Is it on the, the PCB, this PCB, or his independent PCB? But ideally, he said he wanted to use our PCB. But yeah, in case of completing his final year project, yeah, we might have a discussion, make a decision to making other independent PCB, but we will decide. Yeah, thank you. June, do you have any other anything else to report?
Not as of now, no.
Okay.
I'll update everything else on GitHub with the small things.
I appreciate. Yeah, thank you very much. Yeah, because I wanted to know what is listed here. But yeah, you can just report or you can just summarize it on the GitHub. But okay, anybody, yeah, thank you. If anybody can comment on what has been written here, your contribution is appreciated. But I'm not seeing someone from avionics.
I'm the one who edited.
Okay.
Oh, so okay, you want me to explain? Oh, the flight computer. 75% was we've not yet tested we've not yet tested logging data to the flash memory.
Mm-hmm.
That's what's left. Then ejection PCB, I gave it a 0 because we are creating it from during the last pop test. It took almost a minute for the launch for the ignition to occur. So we'll be creating a new ejection PCB from scratch. Then yeah, sensor data acquisition is complete. Or video transmission, yeah, 80%, because what's left is transcoding. Like the data can't appear, the video can't yet appear on the base station on the web application. Though you can play it on VLC on a laptop, the video is transmitted, yes, and you can play it on VLC, but it can't play on the web application. So I'm working on that currently, setting up a streaming server that's compatible with web applications. Then antenna integration. Okay. Yeah, I don't know what percentage it is then. Antenna stand. Oh, yeah. During the drone test, there was an issue that we need a stand for the ubiquity to be placed during the launch. It's not yet fabricated, so we need to design one. Then flight software, data logging onto external flash. Yeah, that's testing. Apogee detection. During the drone test, we did not test the apogee detection. So I was thinking also if it's possible we order another drone test soon to test the apogee detection. Then if you may go back to the Google Sheets.
Moment.
Integrate flight control software. Oh, yeah, we will collaborate with the final year student working on that so that we can integrate it, though we've not yet started. Then filter, yeah, the Kalman filter. We are currently also testing it. Okay. Yeah, so we're not sure. We've not yet. It's not yet definitive. We are still working on it. Then error handling. Error handling is like during the drone test, we discovered that once Wi-Fi connection, if anything happened during maybe it loses the connection, it can't, like everything just crashes. Even once the drone was back in range, there's no data was being transmitted still. So in case of there's also this issue if a sensor gets dislodged, also the whole of the code just crashes. So we were to look into that. Then on the base station, video display, I've already talked about it. Then flight trajectory projection. What was I writing? Oh, there's this feature that maybe if we lose data transmission at some point, we can try to calculate where the rocket lands so that you can locate it later. So yeah, I'll put it in writing so that it's easier. Then calibrate the 3D rocket visualization. Oh, okay. How can I explain that? For the base station, yeah, we added the 3D model on the base station, but it's not yet complete. It does not show the rocket orientation accurately. So yeah, we'll work on that. Then automate data logging. Data logging currently we have to start it manually by executing a certain script. So we wanted to automate it such that it's just once data is received, it logs the data immediately. Then pre-flight sequence. On the base station, we had to add a feature that during the countdown, we go through checks and everything to confirm if everything is working correctly before the launch, before the ignition or before the launch starts. So yeah, those were some of the items that from batch 2 that were left in terms of recovery.
Okay, yeah, thank you very much, Samson. Let me comment on something. So my overall comments are like this. So you have many outstanding tasks at this moment. And so in that case, we have to, considering our limited resource, we have to put the priority on each task. And what I heard about error handling. So this is the most critical because it stops everything, right? So if this happens, I understand that this telemetry stops and, it sounded a very serious issue. So I think we have to sort out this one as much as, as soon as possible. Then also, yeah, basically the priority is the issue. So yeah, I think yeah, you may be creating some, I'm not sure, priority or what, but
Yes, I'm trying to create a priority list. Let me do
thank
that.
you. Thank you, John. Yes. And so apogee detection, of course, if we cannot detect apogee, it doesn't make sense. Kalman filter, yeah. Also, we are relying on the Kalman filter. Yeah, this must be the high priority. Yeah, yeah. Basically, yeah, those are high priority. Integrated flight control software. Yeah, that will be discussed later. Video, it is still important, but I think the secondary. Yeah, video is a secondary, let's say, because the telemetry data is the most important, like the orientation and the GPS, such things. So video is something nice to have. So yeah, flight trajectory projection. Yeah, so this is also something secondary. 3D rocket visualization, this is also secondary. Automate data logging, yeah, should be high priority. Pre-flight sequence, I'm not, okay, I was not fully understanding, the details. So, but yeah, you can decide the priority. Parachute ejection, my concern is there is nothing listed, and this is the most important. So I think you need to list the remaining tasks. Yeah, considering the fact that we have never confirmed the successful parachute ejection by test. Yeah, so before launching, we have to make sure this parachute ejection is complete. Video transmission, antenna integration, antenna stand. Oh, antenna stand. Yeah, that's what we have been discussing. So this year we have to have a stand. Okay, so there should be no one who is holding it. PCB, flight computer, ejection PCB. Okay. Let's see. Okay, so I also request the avionics team to work on the GitHub issues and also the GitHub projects. Yeah. Any other issues from avionics team, recovery team? If not, thank you very much. Can we hear something from airframe team? Maybe Lawrence? Lawrence or Jeremiah?
Yes.
Yeah. Good evening. So can we hear update from airframe team?
Yeah, good evening. Sorry for arriving late.
No problem.
Yeah, basically what we still have is the fabrication of the remaining aluminum airframes. And for that, we are still waiting on the rivets. The one that we had ordered to be brought from abroad.
Yeah.
Yeah, but I communicated with Samil concerning the same, and he was advising that we fetch the rivets from the local vendors around the industrial area in Nairobi, because we are still waiting for the ones to come from abroad, and it seems that it is taking quite a while. Yeah, so I was about to prepare the quotation, and I'll send it to you in terms of the acquisition of the pop rivets, and probably next week, if I find time, we can get to the place and look for the aluminium rivets if we find them available.
Yeah. Thank you very much. Yes. Yeah, let me update. So about the rivet, I met a supplier who we are ordering from maybe 2 weeks ago, and he was saying there was kind of a tragedy. So we are procuring this rivet from I heard, he was using FedEx, and FedEx had a local contractor in Kenya, who is forwarding this shipment, but this company was banned by the KRA because this company was said by KRA that they were not complying with the regulation of KRA. So this shipment was never cleared at the airport. So this item was, I don't know, confiscated or maybe sent back to eBay. So this delivery was basically canceled. And due to the policy of the eBay seller was willing to send another batch to us. So we are still waiting for the item coming. So this is an update, and it is a good idea to still find a local supplier. So I support. So kindly get the quotation and forward it to me.
Okay.
Yes.
And also, we did not complete fabricating the nose cones. Now for the remaining aluminum frames, because we are also waiting for the rivet so that we can roll and fit the aluminum tubes together before we can actually insert the nose cone. So we are ready to 3D print the remaining nose cones. Yes.
Okay, so you are saying the rivet is only constraints.
Yes, as of now.
Okay. How about the parachute? Because we are discussing, we are going to launch 5 rockets. And
Yes.
is it possible for us for your team to prepare the 5 sets of fins, parachute, nose cone?
Yes, it is possible. Actually, we have 4 parachutes. We have 4 parachutes.
You have 4 parachutes?
Yeah, if you can remember well, we used actually the 5th one we used it to narrow down or to scale down so that we could do the other test. So we still have one more that we need to fabricate so that we can have every tube with its own parachute. But we have the 4, which are already attached the short lines to, but we still have to attach the shock code now to the airframe body
Okay,
tube.
all right.
Yeah, that is the only thing remaining in terms of the parachute fabrication.
Okay, so 4 parachutes out of 5 are ready. That is good news. And nose cone, so 0 out of 5.
No, let's say 2. We have 2.
Oh, you have 2. Okay.
Yeah.
And waiting for rivet.
Yeah, but we can still continue with the 3D printing of the aluminum nose cones. Yeah, it's not an issue. Yeah.
Oh, good. So yeah,
yes.
Kindly proceed. Yeah, we have to do it as fast as possible. How about fins? So we need to prepare 20 fins. How many out of 20?
So I'm seeing that you've indicated 4 fins for each rocket. I think it's inaccurate because from our design for the aluminum fins, we decided to settle for 3 fins per tube for each aluminum. Okay, from our simulation, we used 3 fins per tube for the aluminum.
For glass fiber, it's 4.
Yeah, it's 4, and they're already attached. They're ready.
I see. So in that case, it's 8 plus 9, it's 17.
Yeah. So for the aluminum fins, they're not yet attached to the body tube, the lower body tube, because we are planning to use the rivets.
Okay.
For the attachment.
I see. Oh, but all of them are ready in terms of fabrication.
The fins, yeah,
yes.
We only have one because we ran out of the material for fabricating the remaining fins.
Okay.
The aluminum sheet, we ran out of it, so we only managed to cut for one body tube. Yeah.
Okay, so you need to procure another aluminum sheet.
Yeah, but just a small piece so that we can cut out the fins.
Okay.
Yes.
Thickness? How much?
1 millimeter thickness.
1 millimeter thickness. Oh, good. So
yes.
I think June was mentioning there was remaining aluminum sheet, and she's going to use it for her antenna. So
yeah, about that, whatever she was using was, I think, 2 millimeters thick, unless she bought another one, but she had asked me before on that, and I told her that whatever we were having was only 2 millimeters. That was remaining. Yeah.
Oh, okay. Well, yeah, I wanted to know, so do we need to order another 1 millimeter thickness aluminum sheet or not?
We should.
We should, good. So kindly
Yes.
get a quotation and forward it.
Okay.
Good. All right. Get quotation for 1 millimeter aluminum sheet. Great. So in that case, we need to list another issue, which is film fabrication.
And also,
Yes.
I know that my team was also responsible for fabricating the avionics bay.
Oh yeah.
Yeah, so we've not yet done that.
Good. Good point. So one. Okay.
Yeah,
So,
and for that we need to liaise with the recovery team so that we can have we can see how well we can accommodate everything that they're planning to get on board.
right.
Yeah. So as I was still waiting on them on that.
Yes. So recovery team. So I understand you are currently finalizing the PCB. So kindly liaise with the airframe team because it is important to know the final dimension. All right. Maybe. Yeah. Say 5 pieces. Good. Anything from others? Oh, let me go back to Ruth. So Ruth is working on the telemetry system for her final year project. And do you have any suggestion for integrating your function to the PCB or avionics? If you can comment. Hello, Ruth. Unfortunately, I cannot hear Ruth, maybe because of the audio issue. Yeah, so what I wanted to hear from Ruth and even Jones and Safa was that how do you integrate your project to the rocket? So we have 5 rockets, and are we integrating all of the rockets with your projects, but or do you request to integrate your programs on some or one single rocket? Okay, if you cannot comment at this juncture, maybe you can share on WhatsApp or Discord, and yeah, share your opinions. So maybe on chat, you anticipate to use at least 2 rockets with your telemetry designs. Good. So in that case, do you require independent PCB? So if so, how many PCBs are you going to prepare? And what is the mode of the communication with the other PCBs, with the power distribution board, how to interface? So yeah, this issue should be addressed. So kindly clarify the details and share. Yeah, I hope Ruth get it. All right. Anybody wants to say something else before close? I'm going to summarize the discussion and post it on the WhatsApp group. And I have seen the comments from Ruth. The boards will be the same as those of patch 2, only that you will change the mode of communication. Okay, that's in order. That's I think that's easy.
Yeah, I had a concern.
Oh, Jeremiah, go ahead.
Yeah, so about the fabrication of the avionics bay, for example, and the nose corner.
Yeah.
Yeah, we need more filament for 3D printing.
Okay, that is noted, and I have secured a couple of filaments, so you can use it.
All right.
Yeah, so you can just work. You can start working from tomorrow.
Using the printers in IPIC or the ones in ELB.
Both can be used. So which one do you request?
Both, so that we can print simultaneously.
I like it. Yeah, you can use it.
Okay.
Yeah, thank you, Jeremiah.
I had a concern for the ejection test.
Yeah.
Or maybe what update June gave us.
Mm.
So she said that we might to redesign the piston that broke during the last test.
Yeah.
So I will ask maybe members of the team to just share the design or a model of the piston they currently had, because my concern was that they want to move from 20 grams of piston to 10 grams.
Yeah, thank you, Samuel. I was not able to hear because of the connection issue, but so you are pointing out the ejection test issue, right? And so and you also requested to share information or design data, right? Okay, yeah. So let's follow the instruction. Right. Thank you, Samuel. Anybody wants to say something? Yeah, I can see Samuel Otieno. So welcome to the team. And have you decided which team you're going to join?
Yes, I decided. I'm not sure if you guys can hear me, but I made the decision, yes, and I joined the recovery team or WhatsApp group chat.
Ah, good. Thank you very much, and thanks for your contribution.
Thank you.
Yeah, thank you, Samuel. And another comment from Samir is that we could go through the model and check to see if we can reinforce the components to be more on load bearing. Oh, yeah, so possibly. And recheck the strengths and reinforce do the necessary reinforcement. Yeah. Reinforcement. All right. Oh, by the way, so if do you have any video for the fracture? I mean, the failure of the ejection test. Eric.
Can you hear me?
Yes.
Yes, there's video, but it's not in enough detail to show out of the stuff that's simple. And at any picture, the explosion stuff I feel. It's not as informative as the pictures, I think.
Okay, thank you. I request Eric to share the last ejection test because I personally didn't check what was happening. So video, photos, or other details, write up. So kindly share if you have anything. Right?
The video, but for those who have seen it, is the presentation in the Discord.
Okay, Discord. Okay, please. All right. Any final comments? It seems you are good to go. Okay, so thank you very much for joining. I think we can close the meeting here.
Excuse me, sir.
Yes, June, go ahead.
Before maybe just a question.
Yep.
Going forward, could we kindly set particular times for when we'll be meeting, just for us to be able to psychologically and physically prepare ourselves going forward?
Okay, okay. So are you comfortable at 5 p.m. on Sunday? 5 p.m. on Sunday, like today, and 1 p.m. Wednesday. Jeremiah says no. So maybe Jeremiah can propose. The idea is that we want to have twice the short meeting.
Oh, it's okay. It's okay.
Oh, it's okay?
Yeah. It's okay. Yeah.
So the proposal is 5 p.m. on Sunday, 1 p.m. on Wednesday. The idea is that, it's an interval, right? Sunday and Monday, Tuesday, and Wednesday, and Thursday, Friday, Saturday. Yeah. Yeah, it seems it works. Okay, I can see some ups. So yeah, let me set the time for this. Then we will see. If it doesn't work, we can just adjust. All right. So thank you very much. Even though it is holiday, your contribution is appreciated. And as I mentioned, our timeline is very tight, but I'm glad to see the good progress. So we will make it in time. So once again, thank you very much and have a nice evening. See you in the next meeting. Bye-bye.
Bye.